Um, Hello guys. Okay, today we are doing continuity for calculus A. My name is Jacob. Let's get started. Okay, as you can see, the color in red is the topic we are doing today. So by now you should have been done with your basic limits, your absolute values, and trigonometric functions. So today we are finishing it off with continuity. So first of all, we have to understand what is continuity. So a continuous process is the one that takes place gradually without interruption or abrupt changes. So in terms of a formula, if you check it in terms of a graph, in terms of a graph, if I have a graph like this, let's say I have a straight line. This straight line is continuous because there's no any disturbance anywhere, right? But if I have another graph, more or less like that one, have a graph goes like this, then it stops here, then it starts here, goes like that. This graph is discontinuous. It's not continuous. It's discontinuous at this x equals to 0 line. You see, that's your continuity. So the moment the limits of the graphs are not the same, then the graph is discontinuous at that point. So if you check the limit of this graph here, it's here at y, let's say y2, and the limit of the other graph is at y1. So we can see y2 and y1 are obviously not the same, but if they were the same, then it's continuous. So that's how you're going to check if the graph is continuous or not. So let's start here. So a continuous function is continuous if the limit of f of x approaching a from the left side and from the right side are equal, like the graph I just showed you. From coming from left, if the limits are on the same point, which means the limit from left and right are equal. So now if the above, which means this condition, if this condition is met, yeah, then the limit of f of x will be the limit when you substitute that value of a. For example, if I determine limit, let's say x approaches 2 from negative, then my answer is 4. Then I'm also determining the limit of x approaches 2 from the right side, my answer is 4. So which means the limit of x approaching 2 is 4. But if these two are not the same, if this is not the same as this, therefore we say the limit does not exist. So we'll say the limit of x approaching 2 does not exist, like that. So here's example we have here. They said determine if the function is continuous or discontinuous at a equals to 2. A equals to 2 is the same as saying x equals to 2. So what do we know? We have two functions. One function is the left side of a, which means x approaching 2 from the negative side because it's less than 2. The other one is from the positive side. You see? So this is what we are going to do. Determine the limit x approaching 2 from the negative side. What's the function of f of x? It's 1 minus x. We're going to use the appropriate function. So now substitute 2. If I substitute 2, you can see my answer is minus 1. Now if I determine limit from the positive side, the function of x approaching from the positive side is this one because it's greater than 2. If I substitute 2, I have 4 minus 4, which is 0. So therefore you can see f of x is discontinuous at a equals to 2. If they were equal, then you say it's continuous. If they are not equal, it's discontinuous at a equals to 2. Because those two are not equal, they should be equal. Okay, let's do some questions from the exam papers. Okay, before questions, this is the question we just did, and they ask you to draw this. Remember, we calculated that the limit approaching from negative was negative 1 minus 2 was negative 1. The limit approaching from the right side was 0 of fx. Sorry for the way I wrote this. Okay, let me fix it. So the limit of fx. Yeah, we just calculated these two limits. So now, how do you draw? We have x, we have 2, and we have 2. Yeah, that's the point we need. We have x equals to 2. So we have this straight line is less than 2, which means this side of 2. So but it's less or equals to 2, which means at 2, remember, for less or equals to or greater or equals to, you will use a round with a shaded round, but if it's only less and greater, you will use unshaded round, which means that point is not included. So when x is 2 for this graph of 1 minus x, what's your limit? Your limit is minus 1. So if I put minus 1 here, then which means that point starts at minus 1 and goes where? You should draw a straight line. We know 1 minus x means your graph is negative gradient, or else just substitute any value for x except 2 to see what will be your value for y. For example, if x is 0, my y is 1, so which means my graph will go this way until it will end here, because it's limited to there. It's straight line. Now for x squared minus 2x, it's a parabola, so x is greater than 2, and when x is greater than 2, our limit was 0, so which means it will start here, but you use a round line and it must be greater than 2. And we know a parabola, you draw that shape. So this is how you draw the graph. So sometimes they give you the graph and they want you to determine all these values, but most of the time they ask you to draw the graphs. So let's get to our questions. This is June 2020. First question, find the limit as x approaches 2. The next question, sketch the graph. So if they want the limit for x approaches 2, it means we have to find the limit for x approaches 2 from the left side and limit for x approaches 2 from the positive side. If they are equal, that's your limit. If they are not equal, the limit does not exist. So let's check. If x is less than 2, the graph we have where x is less than 2, it's x squared only. So we'll use x squared. So if you substitute 2 for x squared, you have 4. If x is greater than 2, it's here. X greater than 2, it's 3x minus 2. If I substitute 2 here, I have 6 minus 4. So my 6 minus 2 is 4. Therefore, you conclude, therefore the limit as x approaches 2 for f of x is 4. If this were not equal, you're going to say the limit does not exist. That's the question there. That's what they wanted here. Then the next question, they want you to sketch the graph. So we have 3 graphs. We have straight line, parabola, and straight line. So we have point from 0. We have 0 and 2 our points. So draw like this. We have 0 and 2. So first we need to know the limit when x is 0. If x is 0, the limit is 0. It's 3. I hope we can see it. If we substitute 0 there, the limit is 3, and your 0 is not included, so your y it's 3 but it's not included, and it's a straight line. So where do we get another value? Just substitute any value for x. If I substitute any value for x but which is less than 0, if I substitute -1 plus 3, it's what is positive 1, so which means y is 1, so they will meet somewhere here. So which means your graph, I just need the direction of the graph, so which means the graph will go somewhere there for 2x plus 3. We are done. Now we go to the next one. It's parabola. It's from 0 to 2. Here they made mistake. Oh, it's me. I didn't type it well. It's 0 less than x less than 2 less or equals to 2. So from 0 to 2, that's your parabola. So and they are all included. So when your x is 0, what is your y? Your y is also 0. When your x is 2, what is your y? Your y is 4, because 2 squared is 4. And we know 4 is indeed our limit, so it will end here. Then you draw your parabola in a parabola shape. Then the last one, we have 3x minus 2 greater than 2. So we know the limit of 3x minus 2 is also 4. So which means it will start at 4 and go greater than 2. Or you can substitute 2 times 3 is 6 minus 2 is 4. Then this one will start at 4 going to anything greater than 2. So we need another point to see the direction. So if you substitute anything greater than 2, you can substitute 3. So 3 times 3 is 9 minus 2 is 7. So it will go upwards. Obvious, here we can't show that round circle because we already have a shaded circle. So it doesn't matter, you won't be penalized because there's no way you can show it. So that's the graph they wanted. Just like that. This is your x squared graph. This is your 3x minus 2. This is the graph they wanted. Okay. Next question. Given the function f of x is 2x if x is less than 0, sin x if x is between 0 and pi, x minus pi all squared if x is greater than pi. Determine the values of x for which the function is continuous. So now we have 2 points. We have x approaching 0 and pi. So we have to determine the limit when x approaches 0 from the negative. And we know if x is less than 0, it's only 2x. Then we determine the limit when x approaches 0 from the right side, which means greater than 0. That will be our sin x. Then we also determine the limit when x approaches pi from the left side, which is less than 0, which is still sin x. The limit when x approaches pi from the right side, which is x minus pi squared. Okay, so let's see. The first one, if I substitute 0, I have 0. Sin 0 is 0. So therefore, f of x is continuous. Remember, if they're equal, it means it's continuous at x equals to 0. Then let's do this one. Sin pi. I know sin pi is it 0? It's 0, yes. Sin pi is 0. Here, if you substitute pi, pi minus pi is 0 squared, still 0. So which means f of x is continuous at x equals to 0 and x equals to pi. So it's continuous at all the points. If this one was not equal, if the other one was not equal, you only say it's continuous at where it's equal and discontinuous at the other one where it's not equal. Perfect. Then you can conclude, before you write your answer, you can say limit f of x when x approaches 0. It's 0 because they are equal. Even this side, limit when x approaches pi for f of x, it's also 0. And remember, if they were not equal, you're going to say it does not exist. Does not exist. Okay, let's do the next question. Okay, this question is the last one. This time they gave you a graph, and this one was 1 mark each. I think it's 2019 paper. So we can see we have one graph here, which is parabola. The first graph, let me use red, this graph here, and we can see it's less than 2, minus 2 I mean, and we have another graph which starts from minus 2 to 2. So we can see this point is discontinuous because they are not on the same limit. Even this point is discontinuous, they are not on the same limit, right? But the question, they want limit as x approaches negative 2. What's the answer? It's 1 mark. Does not exist. Because you go to negative 2, if you have two different limits, then it does not exist. You only need one limit. Then limit as x approaches 0. At 0, you have only one limit, which is equals to 1. You don't have many graphs. Limit as x approaches positive 2, there does not exist. Because you have two limits. You need only one limit. Limit as x approaches positive 3. Positive 3 is here. So what's the limit? You can see this keeps on going. So the limit is positive infinity. Because it's going upwards towards positive. If it was going down, it's say negative infinity. Okay, yeah, that's all for limits. I'll see you again when we do something else, Swiss theorem or something. Alright, goodbye guys. Don't forget to leave a comment or email any questions you have.